probabilities of various events, and we're told that you may choose a tree diagram. The fact that it said you may use a tree diagram would indicate it's probably the easiest way to do the question. And they've said, let the first event be S, so either S happens or it doesn't happen, and then the second event R either happens or it doesn't happen. R happens or R doesn't happen. Then we fill in the probabilities that we've been told. The probability of R happening given that S has happened is 0.5, which means the probability of R dash not happening at that point is also 0.5. The probability of R happening given that S dashed has happened is 0.4, and for R dash that would be 0.6. And the last piece of information, the probability of S happening is 0.6, so for S dashed, 0.4. The next thing I would do is to work out along the probability along each of the branches. So the probability of S happening and R happening. So that's going to be 0.6 times 0.5, which is 0.3. The probability of S happening and R dashed happening, again, 0.6 times 0.5, which equals 0.3. Then S dashed followed by R, which would be 0.4 multiplied by 0.4, which is 0.16. S dashed followed by R dashed, 0.4 multiplied by 0.6, which is 0.24. I'm now ready to start answering the questions. So for part A, the probability of R happening. R happens here with S first, and R happens here with S dashed first. So the probability of R would just be the 0.3 add the 0.16, which equals 0.46. Part B, the probability of S happening given that R has happened. Well, we've got the two probabilities worked out when R has happened, the 0.3 and R happening here, which is 0.16. So the total probability for R happening, as we've already worked out, is 0.46. We want S to happen, so S will only happen 0.3 out of 0.46, which gives the probability of 0.652. What we want divided by what it's out of. Let's see, the probability of S not happening given that R has happened. Either S happens or S doesn't happen when R has happened. So to work out this, all we need to do is 1 minus 0.652, which is 0.348. Part D, the probability of S not happening given that R hasn't happened. So where R hasn't happened this time is this, 0.24 and 0.3. So that's what it's going to be out of. That's the probability that is going to go on the bottom, 0.54. And where S hasn't happened, that would be the 0.24. This is where S hasn't happened. So that's going to be 0.24 over 0.54, which equals 0.444 or